Hello and welcome back to another episode of Oxford Online Maths Club. My name's James and I'm joined today by Srijan.
Hi everyone. I'm a first year student here. I'm actually at St. Cat's, and yeah, that's about me.
Srijan has very kindly agreed to be on the stream despite not knowing what we're doing on the stream. When was it? It was about Tuesday that we cornered you and got you on the stream. So thank you very much for joining on the stream. Of course, we're also joined by you in chat. Hi to Herb, I can see in chat, and Oscar, Miles, Shrist, and anonymous people. One of the nice things about Slido chat is that you can be anonymous in Slido chat. It's one of the reasons we're not using YouTube's built-in chat. So go there and be anonymous. Shrist is intrigued to find out what a mythological multi-headed serpent sounds a lot like a dictionary definition of a Hydra. We're going to look at a Hydra today. What's that got to do with maths? We're going to find out. But first, let me ask you, how was your day today? I've got a poll for this. Hello, another anonymous person has just checked in. I'm going to choose to believe that's someone who heard me describe Slido as an anonymous feature. The poll in Slido is a vote for how your day is out of 5 stars. I'm always looking out for people who vote for 1 or 2 stars, so they can say maybe your day gets better. There's still time. Srijan, how's your day been on a scale of 1 to 5?
Today's been actually quite. We had 2 lectures this morning, and those were both quite nice.
Ooh.
And yeah, otherwise it's just been fine actually. We've had not too much work recently, so
Not too much. It's kind of the start of term again, right?
yeah.
Second term, so you had the first term that kind of gets busier and busier as second term you're back. I can't remember what the first years are doing on Thursdays. What subjects have you got?
On Thursday, so today we had dynamics, and we also had Fourier series and partial differential equations, which was
we had a partial differential equation on stream last week. We talked about the wave equation, but I think the first years haven't got to waves yet.
We haven't gotten to those yet.
Not quite yet.
We're just about to start the heat equation.
Right. Someone in chat asked about the heat equation. There you go. We've got first year students currently learning about the heat equation, partial differential equation for heat, like tea. Somebody likes my mug. It's got tangrams on. If you would like to search for what these are, you need to search for the word tangram, which is quite close to the word anagram, but not quite the word anagram. Tangram. I feel like I'm advertising like it's a sponsored content, but there are ancient puzzles. I'm about 5,000 years too late for advertising tangrams. Where's my tangram spawn content? Cool. I think I'm having a 4-star day. I put on my jacket. I thought, oh yeah, I'll wear my jacket for. I had an important meeting this morning. I put on my jacket to be smart. Walked out of the building and immediately fell over. Just slippery surface, just went head over heels. Terrible. Didn't feel so smart after that. So that's me. Fonzie's just asked how my day's going. There you go, Fonzie. Right, good. Average 3.9, but it's not about the average. It's about the outliers as well. And the bimodal shape of that distribution. Maybe your day will be improved by fighting a Hydra. Okay. So here's the format. I've got a series of games for us to play. We're going to fight some mythological multi-headed serpents. Srijan hasn't seen them before, so you're playing them for real. And I want people in chat to people in chat to have a go as well. We're going to see how that works. There's a little bit of stream delay. So Srijan, you've got an advantage over people in chat because you hear this first and they hear it with about a 20-second delay and then they have to type. But we're going to give it a go anyway. First, let me describe Hydras to you. Here's how Hydras work. So you have the fearsome Hydra. I thought about looking up a photo of a Hydra, and then I realised that I couldn't, so this is what I had to do. Here's the Hydra. The Hydra has the following property, that if you cut off its head, then it grows back 2 heads. So if this is gone, then it grows back 2 heads. You're a knight with a sword that's specially built for cutting off Hydra heads. The question is, can you defeat this Hydra? If you can, how do you defeat it? And if not, why not? I'm going to let chat have a go at that as well. Anonymous, I sound a little bit different because I'm recovering from a cold. This is my new gravelly voice. Sorry, Srijan, I just talked right over you to explain my
Sure.
flu-like
I think
symptoms.
okay. My first guess is it's not possible unless there is some I don't know, like a really niche trick around this or something. But my first guess is it's not possible because the number of heads just keep increasing.
Right,
But
right. Um, so as you keep lopping off heads,
yes,
you claim that the number of heads keeps increasing.
yes.
Maybe chat agrees with you. Chat says, "How much time do I have?" Or you can't cut it by the neck, not the head. This is a clever solution, I guess. It reminds me of this Gordian knot problem. Do you know this? Where I can't remember the story, but the punchline is really complicated knot. I'll just chop it in half with my sword. Stab it in the tummy. People in chat are mean. It's making the Hydra angry. Right, okay. Kill it with fire. Right, so Fonzie's gone for an equation, which is where I'm going with this. I'm going to discuss this. After you've done a certain number of cuts, the Hydra has a certain number of heads. Sorry. I am kind of interested in how many heads it's got after you've had n attempts at cutting a head off.
Each time that you cut off a head,
Yeah.
you're removing one head and adding two. So you're basically just adding one head each time.
Right, it's +1 each time. It feels like it should be 2 to the power of n. That's what Fozzie's put in the chat. But it's actually n+1. It's not that bad. I mean, that's an increasing sequence. There are n+1 heads on the Hydra, so you're not going to defeat it. It's always got more and more heads. I have done 1, 2, 3, 4 bits of slicing, and my Hydra has now got 5 heads. More and more problems. Okay, good stuff. Good warm up. Philosophy question from Miles in chat, who I think is a math and philosophy sort of person. Given an infinite amount of time, will you eventually have achieved something? Will you have chopped off all of the heads, or kind of the same sized infinity of head chopping as head growing has occurred? I think it's correct that they're the same cardinality.
Yeah.
Do you know about cardinality from the university
Yes.
class? Or
Yes. We did that first term.
Right. So it's about different sizes of infinity, right?
Yes. And
do
so
you-
this is
yeah, okay.
this is countable, right? This is like if it like the actual word is it's countable because it's in bijection with the natural number. So it's like basically you can still like count how many heads are left. Like after you've done infinitely many, there's still like you can still, I guess, number the heads if you think about it that way.
Yeah. Okay. You can number the heads. So it's sort of, if you keep chopping, I guess depends what sort of infinite amount of time you use for chopping heads off. But it feels like it's quite a countable sort of problem. That there's a lot of heads, but not that much. Sort of slightly different would be if you chop off all of the heads in one layer all at once. This is maybe what Fonzie was imagining, some sort of brilliant sword that can chop all the heads in a layer at once. Then the number of heads doubles each time, and that feels to me more like a kind of uncountable infinity, but I'm not really sure. Philosophically, I've got to think about infinite time in here as well. Now, my puzzles are not supposed to be about infinite chopping. Yeah, Super Tasks mention everybody go and watch the Infinity Machines video. On this YouTube channel, there's a video called Infinity Machines, which is about machines doing infinitely many things, if you're interested in a sort of infinite industrial process for slaying hydras, but that's not very nice to hydras. Right. Technically, when you cut the first head, you removed all the heads until it regrew them. Right, yeah, so what sequence does this happen in? Do you get to very briefly celebrate? You slice off the very first head, very brief celebration. I think that might be celebrating before the victory.
Yes.
Okay. Hi, Eb. We're fighting a Hydra. It's one of those things where you cut off a head and more heads grow back. Okay, so this is not super exciting. This is the Hydra from mythology. You cut off a head, more heads grow back. It's kind of where you leave it, I think. You cut off one head, two heads grow back. I was surprised to find that there are other versions of the Hydra in mathematics that are harder to fight. We're going to talk about that now. As soon as Mario reconnects. So I'm going to stall for time while that reconnecting thing goes away. Here's the next Hydra that I want to talk to you about. You see, this branching structure of the heads of the Hydra reminds me of a maths thing called a tree, where you have like a root node. It's got nodes and edges. You have a root node, and then branches come off from that, and then branches from those nodes and branches from those nodes. This one is currently doing something like a binary tree, where each thing has two children going from left to right. But you can imagine a more general tree with lots of heads. Fonzie has just said that Hydra is supposed to start with 3 heads. So we have a sort of more general setting for this kind of Hydra-shaped thing. And maybe there's a game we could play there with a Hydra which is a different kind of orientation, different sort of graph. Right, I'm really not sure this is going to reload, so I'm going to take some drastic measures of hitting refresh and see what happens. Refresh will either make it go away and never come back, or... Oh, hello, something's coming back. Good. A killable binary tree. I think it's unkillable binary tree. It's too resilient to our attacks. I'd like to try and describe a different sort of Hydra. Yeah, so people meet trees in decision maths, in A-level. Srijan, did you meet any decision maths sort of stuff with trees or anything like this?
No, not really, actually.
Because you were in the States before
Yes,
Oxford. And
Yeah,
AP Calculus
not-
BC
not-
and all this sort of thing.
Yeah, and it's not in the school syllabus there. So
Okay. Let me draw you a little tree just to show you the sort of thing that I'm thinking about. So there's one root node. I would like green, please. Can I have green? There's one kind of root node, the body of the Hydra, and then some number of nodes coming off from that. And those nodes might themselves be the root of some further tree. So there might be all manner of stuff going off over this way. And there's no rule that if you only have one child here, that one could have 2 children or something, this one could have 17 children or something. But they work like that they spread out. And I suppose for a Hydra, this bit is the body. Hang on. This bit is the body. The things on the ends that don't have any further children. If you're thinking about it as a tree, those are sometimes called the leaves of the tree. But in here, I think I'm going to call them the heads of the Hydra.
okay.
It's kind of similar to the structure we were building above. Okay, so we've got to find it. We've got a node. We've got this sort of root, which I might call a root. I might sometimes call it the body of the Hydra. And then you've got nodes further down, and some special nodes are these ones with no further children. Those are the ones that you can slice off, right? Somebody in chat was very clever in saying, if we just chop it further down, then it'll die faster and we'll get it. In the games that we're going to play, you're allowed to chop the leaves off a tree. They're used as a data structure in CS. The rules are no cycles and fully connected. Yeah, okay, makes sense to me. Tree. Somebody in chat just said tree in capital letters, which makes me think of something in particular, which I'll get back to you. Okay. That's my diagram of a Hydra. Let me show you what happens when you attack this Hydra. Because if it does the same thing, if the rule is you remove a leaf from the tree and you grow back 2 heads there, we can write that out in terms of trees and nodes and leaves. But I want to describe a slightly more fearsome Hydra. Here's the extra ingredient. Yeah. Here's the extra ingredient. Cutting off the heads makes the Hydra angry. It doesn't like having heads chopped off. Its anger is a sort of measured by a number. The number is, I suppose, sort of number n or something that measures how angry the Hydra is. Each time you chop off a head, its anger increases by 1. It starts off, the first time you cut off a head, its anger level is 1, and then each time you cut off a head, it gets more angry. This is why this Hydra is more dangerous. Here's the rule about how it regrows heads. Are you ready? I've got it over here somewhere. Yeah, here it is. Here's the rule. It's a little bit complicated. Bear with me. Okay, here we go. So the rule is, if you chop off a leaf or a head of the Hydra, which is something with, you can chop the ones that have no further branching beyond them. And I've drawn these ones bottom to top instead of left to right. If I draw them that way around, they look more like trees growing upwards. Sorry, it's what people do. Here's the rule. The Hydra is angry. If you chop off a leaf, it will look back, not just to where that head was connected, A, on this diagram, but it'll look back to B, the place where that was connected.
Okay.
So it goes back to not kind of the parent, but the grandparent of the head you just chopped off.
Okay.
These trees are a little bit like family trees, except then I would draw them top to bottom rather than bottom to top. Never mind. And the Hydra regrows N heads, which are N new leaves on that point.
Okay.
Let me say it one more time because it is complicated. The Hydra. Okay, so the Hydra, you chop off a head, which is this leaf. It looks back to the grandparent of that now missing head, and it grows lots of new heads around there, depending on how angry it is. So it's sort of bad news, right? Because anger level starts at 1, then goes to 2, and then as you do some chopping, it keeps getting more and more angry, and it regrows heads. There's an exception, right? The exception is sometimes there isn't a grandparent. If you cut off something that was connected to the root or the body of the Hydra, that makes it angry, but it doesn't grow any more heads. Because there isn't a grandparent for those ones.
Right.
So it wouldn't know where to grow them. There's this rule about the grandparent, which I'll go from this one to parent, grandparent, to grow them there. Yeah. And I suppose the question is now, you meet a Hydra in the wild that already has some structure. To it. Can you defeat the Hydra? So some starting condition for this game as well. It's a lot. Okay, we'll get there. So for example, let me start you off on a Hydra like this. So here's a Hydra. That's the body or root, and then it's got one node here, and then coming off the node, it's got another head here, and that's the head. So this one is a head or leaf at the end. It's like a long, skinny Hydra. And its anger level is currently, I guess, 0 until you start doing any chopping. Right. Do you want to see what happens as you start chopping off heads?
Sure. Wait, and just to clarify, the root node here, is it the one that's the body or the one that's above it?
The body itself is the root.
Okay.
Yeah. Okay. Anonymous in chat says, yeah. I've gone for two in a stack rather than one, because if there's one, then you chop that head off, and there isn't any grandparents, so nothing else happens, and you win straight away. The Hydra's confused. You've angered it and also defeated it straight away. This one's a little bit harder.
Yeah. So
do you want to talk me through what happens?
Sure. So if you chop it off, if you chop off the first head right now.
Yeah, let's do this in slow motion. Let's go. Okay, so you chop off the first head.
Right, and so now it grows one more head, and
its anger is now 1.
Or sorry, yes, its anger is 1, so it doesn't go back any.
Yeah,
head.
so it grows back 1 head, also connected to the root. It looks down to the grandparent of the one you just chopped off. Its anger level is 1, so it grows back 1 head over there.
And then now you can just chop off.
Yeah, now you chop off the other 2, right? Okay. So it's Hydra defeated. Okay, so this new rule feels pretty pathetic, right?
Yeah. Just for this case, I think.
Just for this case, would you like to fight a larger Hydra?
Yeah.
Let's fight a larger Hydra. Okay. Okay, here's the route. I've literally drawn it larger. I didn't really mean to, but hey. Okay, I'm going to stack together node, root. Node, leaf up here, sorry. Root at the bottom, leaf at the top. My Hydras are getting less and less Hydra-like over time. Maybe I should... Anyway, never mind. So you can only chop off leaves, so your first move has to be to chop off that top head. Off you go, you talk to me.
yeah, so you just chop off the first leaf at the moment.
Yep.
And finger level becomes 1, and then
it looks to the grandparent and it grows 1 head over there.
Okay. And then now it'll chop off both the leaves that they're just like equally. So you can just chop off 1.
Which one would you like, the left one or the right one?
Let's go with the left one.
Okay, its anger is now 2, so it looks to the grandparent of that node, and it grows 2 heads at that level.
Exactly.
Okay.
And then now you chop off the other leaf, the one that was
this one?
yes.
This one. Okay, its anger is now 3, and it grows 3 heads. So it looks to the grandparent, and it grows 3 heads. So it's now got 6 heads.
But it's not. But if you chop off another one, it's not going to grow back anymore. So
brilliant. Okay. Yeah, it gets really angry with you as you slice off its last 6 heads. But those heads don't have grandparents, so you're good. Okay, so you win again. This is pretty good. You win. Okay. The anger is always increasing, so it feels quite dangerous, right? And people in chat are talking about you can always kill it. Does the grandparent lose its head? No. Yeah, so the more heads grow out from the grandparent.
Right.
Yes. What else does chat say? So chat's talking about finding an efficient way to kill the Hydra. There's actually a more interesting question, which is the following: can you lose? So this is. Let me explain the question. I can see. I'm gonna throw it to you as well. Don't worry. To lose the game would mean that the Hydra is growing more and more heads, right? And the game was sort of going on forever. Like that first one we played, where you're always doing stuff, you're taking actions, but the Hydra has got like more and more heads. So you're not going to end up. So far, you've described a great strategy there. I liked watching you fight that Hydra. That was pretty nifty. And people in chat are talking about doing efficient ways.
Right.
So I suppose somebody's asked about perfect play. I think not assuming perfect play. So far I've only given this problem to highly intelligent people in chat and on stream, right? What if I gave it to a very small child and said, look, just pick whichever head you like, right? See what happens, right? And they might accidentally anger the Hydra quite a lot. Especially we've got all these heads down here which increase the anger. If we'd gone for those early, then the anger would have increased quite a lot, and then when we slowly travel down, we get loads of heads. If you can't kill multiple heads at once, you can only get 1 head at once, and the anger goes up. Here by the end here, I think you had 9 moves, so the Hydra anger was 9. Luckily, you were just slicing off lots of heads that had no grandparent, so you were okay. You can't kill an infinite stack of heads, right? Sure. I'm gonna get people to slightly calm down from infinity, briefly. We'll get there. If the Hydra is sort of infinitely tall, then I'm not really sure what that means. Does it even have sort of endless snake? Goes on. Your task is to cut the head off. Well, I can see the body's right here, but the snake arm. Not really sure. Trish says you might lose if the Hydra starts with multiple things coming from the root. Let's try and draw a Hydra that might defeat you, might put up a fight. Maybe puts up a fight against someone who doesn't really know what they're doing, like this Hydra. Because you've got to choose, right, which one you're going to fight. Well, maybe you choose which one to fight, but there's another one still to go before you've finished. what else?
Sure. I'm not too sure if it would actually make a difference whether you start off with just one or you have multiple coming off from the root, because anytime that you do a cut, it would only be on one of the branches. So it's like each of the branches are independent in a sort of sense that it might not. I don't know. That's just my intuition. It might not actually really be making a difference whether you start off with 1, 2, 3, etc.
Right, so you think maybe you could defeat this bit of the Hydra first, and then it's pretty angry, but you reckon you could defeat that one?
Yeah.
Even with the anger
Still,
set to 100.
as long as you're dealing with like as long as the anger level is as long as it's finite, then it is possible. You clear one head, you don't care how much the anger level is, as long as it's finite. I guess it might be okay.
Yeah, so Emo says you can never increase the number of layers, and actually several people in chat are talking about the number of layers. I want to point out a subtlety, so there is an argument you can try that talks about the number of layers, like the kind of height of the Hydra, 1, 2, 3.
Right.
It's totally possible, by the way, that there are some moves. So there are some moves that you do which don't change how deep the Hydra, don't change the depth of the Hydra tree, and don't change the height of the Hydra. There are some moves you can do, and they make it more angry, and sometimes it's regrowing heads. I guess there's kind of a question there about when you do a move, maybe you're decreasing the height of the Hydra. It feels like making progress, right? It doesn't get taller. So if you're decreasing its height, that's good. But some of the moves you're doing don't change its height, and I'm a little bit nervous that there might be a kind of infinite sequence of moves that don't decrease the height. I'm worried that the kind of losing strategy might be out there, that if you never get around to decreasing the height of the Hydra, but you mess around with different side bits of Hydra. Cool says that maybe we can do this with induction, which is an interesting idea. Do you want to say anything about that, Srujan?
Yeah, sure. I think it could be. I mean, I don't know if maybe you can induct on the number of layers, I guess, on the number of starting layers, perhaps, because yeah, I mean, you might be able to come up with an argument there.
Yeah, so Thresher is right. The question we're trying to answer is, do all sequences of moves eventually win? And the answer is surprisingly yes. Anything you do defeats the Hydra, because of you can do this induction argument on the height of the Hydra.
Right.
It's a little bit subtle. Should we try and put it together?
Sure. Yes.
Okay. So let's say that a Hydra with kind of height D, so maybe it's got some really complicated structure or something, but let's say it's got height D, 1, 2, 3, 4, D. Let's say we can defeat all of these.
Okay.
Sorry, writing is quite slow on this Miro board right now. If we can defeat all of these, here's a taller Hydra. So I want to draw something quite general. What's the most general thing that I should draw here? It's got to have height D plus 1, I guess, if we're doing this by induction.
Yeah. I suppose you could draw a node or a few nodes coming off like from another. I don't know how to make it as general as you can in the diagram.
Yeah, which is tricky. Induction, by the way, if you haven't seen it before, is the idea that you build up from small problems to bigger problems. You say, if I can, the things you prove are, if I can knock over a chain of 37 dominoes, then I can also knock over a chain of 38 dominoes, because I know that I can just stick another domino on the end and then it'll all be fine because each one knocks over the next one. That kind of proof style lets you prove things for all natural numbers. You also check that you can knock over one domino at the start. I guess you do a base case. There's that idea that you check that each one implies the next one. Yeah, so, and it is a type of proof that you learn in further maths. People here are trying to use induction not on the number of heads, because there's lots of heads, but on the height of the Hydra. So let's say you're fighting this Hydra of height d plus 1. Then, well, we're imagining, is there a losing strategy? If you give this game to an idiot and they fight the Hydra really badly.
Right.
So I suppose what we're waiting for, this is going to be hard, isn't it? What we're waiting for is, I don't know, we're giving the game to some total idiot who's fighting the Hydra really badly. We're waiting for them to eventually slice off all of these top heads at height d plus 1, because then the Hydra will be shorter, and then we know, they're taking so long, but the game is almost over. Now, I know we can defeat this. I need to rephrase this a little bit, right? Because we can defeat this because we're just going to go and slice those ones and then worry about the rest later. But if any sequence of chopping I've just realised that a sequence of chopping is also called a chopping list. Anyway, never mind. There you've got, oh my goodness, it was right there. Yeah, maybe you're trying to keep your pet Hydra alive for as long as possible while also hacking at them. Okay. So I suppose we're going to have to say, so an idiot fighting a Hydra, they might do some sort of moves on parts of the Hydra that aren't as tall. But that will only waste finitely much time. Maybe they kill all the rest of it. It's produced lots of small bits of Hydra, and they waste loads of time killing all of that, increasing the anger of the Hydra so much. Eventually, we'll have to. So eventually, you fight all the rest of the bits of the Hydra pointlessly, wasting lots of time. We'll have to fight these ones in the blue box. There might be several of them, but once we've eventually fought all of them, then height reduces.
Exactly, yeah.
I think that's convincing enough for the stream. If they chop every head possible, then they will eventually chop the top layer. Yes, because of what's called the induction hypothesis, the idea that the smaller bits of Hydra they can't waste infinitely much time messing around with those bits of Hydra by the induction hypothesis. Yeah. So eventually, the idiot that we're imagining playing this game will get round to slicing off steadily those top ones. Right. I'm using D as the inductive variable, not because of the natural number name, because I was thinking of depth. But yes, with D, HD. Sequence of chopping means the grandpa is never the root. They could lose. Right, yeah, that's the question, I suppose. Is there a sequence where the grandparent is never the root? And the answer is no, because eventually you run out of things to do other than chopping off heads of the Hydra that are connected to the root. There's just only so much stuff above, and even with all the anger producing lots of stuff, the stuff that it produces is closer to the root. EMTC says maybe the number of cuts doesn't matter. That would be quite depressing, because it would mean that the idiot takes just the same amount of work as you do with your clever strategy for killing the Hydra. Luckily, that's not the case. You can be clever and deal with the. Well, do you want to say what's your strategy for killing a Hydra quickly?
Yes. Yeah. I mean, if you want to do that as efficiently as possible, you go layer by layer. But I suppose in this case, like people in the chat were saying, I think it doesn't. If you ignore that top layer of heads, and then you there's only, you know, there are certain nodes that you can't chop off. For example, like the node right beneath the ones that you can't chop off, like you can't chop off those either. But the remaining nodes, you know, you can basically chop. Like if they're leaves or maybe branches on like their own that are not connected to the main branch which, you know, you're dealing with, those are all of like height maybe D, at most D, and so intuitively, you know, you should be able to chop it off. Of course, you'd have to rigorize this a bit more, but
yeah, you'll get down through those. I want to show you a really stupid strategy. I suppose we've proved that all strategies kind of eventually work. So here's a stupid strategy. The stupid strategy is right first, rightmost chopping. I'm going to fight the same Hydra as you, but really stupidly. Okay, here it goes. 1, 2, 3. Okay, somebody in chat is saying that anger doesn't do anything, and I'm going to show you just sort of how disastrous the anger thing is if you kill the Hydra quite slowly. So you know I'm going to defeat the Hydra because everyone defeats the Hydra. But let me show you how badly it can go. I have to kill this one, do this head first because it's the only one. And then I'm faced with, well, so you look to their grandparent and it grows 1 new head. And now this one's the rightmost. So I'm going to kill this one next. Its anger is now 2, and it grows 2 heads over here. Right, now here's where rightmost is really bad, because my next moves are going to be to kill off these 2 new heads that it's just grown. So I'm going to erase that bit. Okay, here we go. My next moves are quite stupid. I'm going to go for the rightmost ones. You ready? So I kill that one on the right, and it doesn't regrow anything, but its anger does go up to 3. And then I'm going to kill that one on the right, and its anger doesn't do anything, but it doesn't regrow anything, but its anger does go up to 4. I might have done this wrong already, actually. Let me think. Yeah, I've made a mistake. Let me quickly think about my mistake. Yeah, I didn't draw back enough stuff. Let me try again. Sorry, rewind.
okay.
I think I found the grandparent wrong. Yeah, I think I counted the wrong way to the grandparent. Yeah, this one, because it should regrow like this, right? Here we go. Yeah. It should count to. Okay, I can do this. I'm not extremely. Anger determines how many heads grow back. Yeah. Here we go. It's not obvious. If you kill a Hydra really quickly, then the anger never builds up, so nobody ever sees anything. But let's go. Okay, so it counts to the grandparent, which is here, and it grows back 1 head. There we go. Is that right? Yeah. Grandparent, 1 head. Good. Okay. Now I'm going to kill that one. Yeah. Okay. Kill that one, and it grows back 2 heads. Yeah, okay, I was doing it right. Fine. You kill that one, its anger goes to 3. You kill that one, its anger goes to 4. And it doesn't regrow any heads, but now it's time to kill this head, and its anger goes up to 5, and it regrows 5 heads over here. 1, 2, 3, 4, 5. That's pretty bad news, because now I've got to do 6 more chops. So it took me 11 chops to kill this Hydra, which is pretty slow. I think you did it in... Where's your attempt? 1, 2, 3, 4, 5, 6, 7, 8, 9. Quite a bit faster. Okay. The next height of Hydra would be one with 4 in a stack, and things go really quite badly wrong for me with my rightmost chopping strategy. We know it's going to kill the Hydra, but it takes, I think I wrote this down, it takes almost 1 million turns to kill the Hydra with a stack of 4 nodes like that together.
Well, and if you do it rightmost chopping.
If you do rightmost chopping, because, well, in a way, for me, these heads are growing back on the root, so they're now fine. But if there's an extra head, it doesn't quite work like this. But if there's an extra head around, then if the root was further away, then the angle would now be 11, and I wouldn't be done. I'd have more chopping to do, and they'd have all regrown approximately 100 other heads around there. Am I going to do a demonstration of the million chopping Hydra fight? No. For Hydra fight 5 or height 6, I think nobody's done the calculation for how long it would take to defeat those Hydra. It grows faster than any function you can realistically think of right now, except for the people in chat who are shouting tree. Okay. There's only one place I'm taking this, I'm afraid, which is we've got to try and describe the Kirby Paris Hydra. Let's do a very quick break to infinity. People seem keen on infinity. In particular, they're talking about strong induction. Have you met the difference between weak induction and strong induction?
Yep.
Do you want to describe it?
Sure. So strong induction is just a form of induction, but it's just that whereas in induction you say your inductive hypothesis is if it holds true for n, then it's gonna hold true for n plus 1. Strong is just if it holds for everything like from 1, 2, 3, like up to n, then it holds for n plus 1. So
Sure.
it looks stronger because you're assuming the bottom end, whereas it's just in the normal induction, it's just the one below.
There's an even stronger sort of induction called transfinite induction. Which lets you go past infinity. You need another sort of step to get past infinity. In regular induction, you prove the base case, you prove the successor case, so for each n, you go to n plus 1. Transfinite induction adds, and also check whether you can go past limits. So if you have something that's going off to infinity, to check that the infinity domino also falls over. It's not always true. It's the thing, even though it's a stronger proof technique, it doesn't mean the thing you're trying to prove is actually correct. I kind of want an example. Let's try and think of an example of something where it's true for all n, but it's not true at infinity.
Okay.
Is that something we can give an example for?
I don't have one off the top of my head. There was a problem in my lecture notes. Which was a bit, but it was like a bit technical with sequences, so I don't know.
Yeah, I was sort of thinking about functions where you can imagine like a sigmoid function that kind of goes from 0 up to 1 with some sort of slope, and then you imagine maybe a steeper one. And these are all functions that are nice and don't have any jumps in them, but kind of if this is 1, 2, 3 for how steep they are, the kind of infinity limit of this or something is like a straight up jump, and then that's not a continuous function. But that's not a great example, is it? Because I'd have to explain what continuous is. You know, something where it's nice and smooth, technically smooth, but then at infinity it's got a horrible jump in it. You can't always go to infinity and beyond. Something called transfinite induction, which I'll put a link to in the further reading notes, which get posted on the Maths Club website afterwards. Essentially what you might do is to say Hydra with n heads on, Hydra with n heads is weak to me. We can defeat that Hydra really easily for all n. You know that you're winning when you fight this Hydra. There's no grandparents for these nodes. So
Yeah.
you know you're winning because the number of heads decreases. So sort of the power level of the Hydra, it's like level n, is decreasing as you go down. Even if it starts with over 9,000 heads, then eventually it will have under 9,000 heads, and so on down to no heads at all, then you win the game. So it's kind of weak, whatever the number is. And then this Hydra, with one head on a stalk, it's clearly stronger. It's got 5 legs as well. It's clearly stronger than all of those Hydras. This Hydra is clearly stronger because when you cut that top head off, depending on its anger, it could grow any number of heads.
Right.
So this is clearly a stronger Hydra. We still defeat it. But one chop reduces it to a weak Hydra.
Exactly. Yeah.
Okay, so transfinite induction kind of relies on the idea that you can set up ordinals, which is sort of this number system involving infinity, where you would give the number infinity, or sometimes written omega, for this Hydra. And that's kind of a number that's considered larger than any natural number, like this is 4 for this Hydra here, infinity larger than 4. But when you chop heads off, you know that you're decreasing the kind of value of the Hydra, the number associated with it, which means that you've got to come down to a natural number. The only thing smaller are natural numbers. The ordinal system of numbers is really interesting. It includes stuff like omega plus 1, but not omega minus 1. This one represents a Hydra, I guess. Omega plus 1 represents the Hydra with like one head on a stalk, plus also one head not on a stalk. Omega minus 1 doesn't mean anything. Doesn't represent any Hydras.
Right.
They're cool numbers. They don't have subtraction. They do addition. So then reducing it to a smaller number means you have to reduce it down to a natural number. And the Hydras line up quite nicely with these ordinals. Somebody said ordinals ages ago, and now they're happy. Yeah. So this is different from talking about having an infinite number of heads. And it's why I tried to get chat to calm down a bit from infinitely tall Hydra and infinitely wide Hydras earlier. Because the Hydras kind of include infinite possibility, despite only having a finite number of nodes or heads. Infinite possibility is kind of different from a literally infinitely wide Hydra. Thrice shy, very happy, good. Right, okay, I've got to describe the Kirby Paris Hydra. This entire live stream was inspired by... I'll tell the story in 15 minutes, I think, because it's funnier if I do it afterwards. A friend of mine said I had to explain the Kirby Paris Hydra, so I'm gonna do my best. The Kirby Paris Hydra has got a different rule for what happens when you chop off a head. It's similar, but slightly different. Let me try to explain it. I'm going to draw some Hydra that's in the middle of, some stuff. Maybe it's got more stuff going on here with three heads over here. And you're going to cut off this head and look at its parent and look at its grandparents. It's kind of similar. And it still has an anger management problem, that it has some anger level N. What it regrows, I'm going to put one more node here just for fun. What it regrows when you chop off one head is not N heads attached to B. It regrows N copies of A, and everything joins to A from B, attached to B. So I take all of this stuff that I just drew with the basic bit A, and I draw all of that on B. N times. Do I mean that? Have I drawn them too far down? Let me just quickly think. Tree rooted there. N copies of that, yes. So loads. I'm going to now quickly try and draw N for some reasonable value of N. Oh dear, that's gone quite wide. Plus all that stuff that was originally attached to B as well.
Okay.
So you only chop off leaves. You're chopping off. So far in the game, you've only been allowed to chop off leaves, and that's still true. You're only allowed to chop off leaves. These Hydra have got these kind of weird joints and branches, and like a tree, I guess. They got these points where they branch off from things. Maybe I should be colouring in some of these joints so that you can more clearly see the bits that you're allowed to chop, but I don't know. Okay, so it grows back N copies of the tree attached to B.
And so B here is the root node, or is it like
B is the grandparent of the place where you did the chopping, just like before.
Okay.
So it's kind of growing lots of new heads and lots of new structure, including N copies of the thing. But They're all one layer closer. They're attached to B rather than being attached to A. I think I've got that right. I was suspicious. It's possible I might need a citational correction that appears in the further reading. But I'm pretty sure that's how the Kirby-Paris Hydra is supposed to work. This one is still unlosable. We still win. Good job, chat. I was going to ask Regan as well. What do you think about this Hydra?
Yeah, I mean, it's same logic as before, right? I mean, you can still decrease the number of layers. I mean, basically, no matter how you chop it, you're still moving things to the layer below. So I would think that it's still unlosable.
Yeah, and you're right. You still can't lose when you try and defeat this Hydra. It takes a lot longer. A call in chat is correct. So well done, people in chat who said, yeah, you still win. It's interesting for two reasons. Now, we defend this. I've spent quite a bit of time describing a new Hydra. It's interesting for two reasons. One, the proof that you never win, that you can't lose, needs extra axioms that the previous Hydra didn't.
Okay.
Sort of technically harder. It's not. I did try to memorize this. It's not the sort of thing that I'm very comfortable saying. It's not in piano arithmetic or something like that.
Okay.
There's some modification. There's some extra axioms that I don't understand. Extra logical systems. It's somehow harder to prove that you can defeat this Hydra. I don't know why that is. But I think some of it comes down to being stuck in loops, right?
I think so, because like the earlier claim was no matter how you chop it, you won't lose. So that just amounts to saying, no matter what sequence I choose, I can always, like, as far as the inductive principle goes, no matter what sequence I choose, eventually you'll end up picking the ones in the top layer. But like at the same time, it kind of creates a sort of difficulty, and there could be like what you said, there could be loops, and so you have to maybe insert extra axioms for that.
Sorry, chat, I should have said axiom is a word for the kind of very fundamental mathematical idea. It's the sort of things that underpin induction. So the idea that every number has a next number is one of the axioms of arithmetic. It sounds really obvious, right? But that's kind of the point. It's so obvious that it doesn't have a proof. Axioms are fun. They're kind of the very first building blocks that we've got, and it was part of the sort of axiomization of mathematics to try and find out what those fundamental blocks are. What are the most basic pieces, atoms, if you like, that you need in order to build all of the rest of mathematics, things like strong and weak induction. This formal rigor is really important for discovering that some facts are unprovable, some facts are independent from the axioms that we had, which is weird. There's a famous one called the axiom of choice, which is a relatively modern axiom that we didn't realise that was independent from everything else. So a fact that we thought maybe you could prove, or maybe you could use the other things to put together, was actually a kind of logically distinct idea. Maybe that's what axioms are, I suppose, logically distinct things that don't follow from each other. Yeah, complexity. They get a lot of... It's really odd to me, and a sign that I don't understand formal logic very well at all, that it still feels like to me, yeah, you just defeat it in the same way, right? It's like levels and induction, right? And what the mathematicians are telling me is that I'm being too cavalier with the way I'm using the induction hypothesis, or maybe with what induction actually is. So there's something very dangerous under the surface for this Hydra. In terms of mathematical rigor, I suppose, at the very smallest layer. The other fun thing about this Hydra is that if you do the stupid thing of chopping off the rightmost head each time, then you get an incredibly quickly growing sequence. I think this one takes 37 chops for Hydra of height 3, and then the number of chops that it would need for a Hydra of height 4, which was 1 million for our previous Hydra system, would now be like more than Graham's number. No one's calculated it. Super huge. The sequence grows faster than tetration or any of those sort of things. And I really like these as a way to kind of get into the weirdness of axiomatic set theory and sort of some ordinals and numbers.
Okay.
Do you want to say anything about the Kirby-Paris Hydra?
I think there was that one comment that said that the ones that regrow are less complex than the original one. I think I just have one comment, is that it's true they're less complex, but the thing is that with this anger number, it's just like, I think the reason why you kind of need these additional axioms perhaps is that you have this additional this anger management problem that's just like, you're creating copies, they're less complex, but you're creating so many more copies eventually that's just like, it's going to be very hard to rigorously, I guess, prove whatever you're talking about.
I guess I'll link people to the paper that Kirby and Paris published. That
Yes. Yeah,
the axioms that you need in order to prove this.
Exactly. This is one of those proofs that are just more like, it's hard, like it's easy, it's maybe easier to intuitively understand, but then when you try to put pen to paper, it's just, how do you write it? Like it's probably one of those types of proofs, I'd imagine.
Yeah, and something behind this is that intuitive arguments can be wrong, but quite convincing. And that's something you have to be very careful about. That things that sound like they make sense might not always be correct. I forgot to do an ad break. You're right. Good spot. I was going to ask you something about adding. I guess we sort of did a little bit, but adding 2 Hydra together, right? So you're if you can kill this Hydra and you can kill that Hydra, if like add them together by merging their roots. But it seemed like chat was pretty convinced they could defeat that Hydra. You're sort of adding the Hydras, which then in this world is like adding together the ordinals.
Yes.
So Kirby and Paris describe a more general way, by the way, of describing what numbers these Hydras represent, which is that you start by writing 0 on each head, which will probably annoy the Hydra, but never mind. And then you write the sum of omega to the power of each of the heads on the parent of each of those, which to start off with is just the sum of how many there are. So this gets 2. This is 1. Oh no, sorry, not yet 1 because I haven't done this one yet. This says omega to the 2, and this says what am I going to write here? Omega to the 2 plus 1, and this one it means another 1. So you end up with omega to the omega squared plus 1 being the number that this Hydra represents. And that's kind of cute. I think that the exponentiation kind of matches up with the depth of the Hydra, and the addition matches up with the kind of parallel bits of Hydra. It's all very, the numbers represent how many there are, how many actual leaves there are at that level, and then I suppose the Kirby-Paris proof talks about sort of transfinite induction on those ordinals to get back. The most effective way to win is to simply make friends with the Hydra. Yes. Excellent stuff. The real friends with the Hydra we met along the way. Wait, let me find a Hydra and make it look happier. Oh, they're all dead. No, this one's not dead. This one is maybe pet. Or you teach it anchor management, so that it doesn't regrow quite so many heads. Very nice. The story behind this is a friend of mine said that when they were a kid at school, somebody came in and did a talk about the Kirby-Paris Hydra, and the only reason they remembered it is because it had gone really badly, and no one had understood the Kirby-Paris Hydra at all. So my friend told me, you do this maths live stream thing. You've got to talk about the Kirby-Paris Hydra, and now I've talked about it. It's not gone very well. But I do like a challenge. If you like a challenge, then you might enjoy 70 episodes of the Oxford Online Maths Club, which are all available to stream from our homepage, which is maths.ox.ac.uk/r/club. That's also where you can get further reading notes for today's episode. We usually post them Friday afternoon, so that you can have a look over the weekend. That's where you find corrections and other things to read if you're interested in anything you've seen on the stream today. It's also where you can find out about the Mathematical Institute and our other supporters at Jane Street, a financial trading firm. But I think we're wrapping up. So I'm going to say, Srijan, do you want to say anything else to people watching at home?
Yeah. Sorry. I hope it's been quite fun. I think this is a really interesting topic, and I hope you've also enjoyed it. And yeah, I guess see you next time.
See you next time, indeed. We'll be back in 167 hours for another episode of the Oxford Online Maths Club. Take care. Bye. Oh, there we go.